Dr. Thenathayalan from Department of Electrical and Electronics Engineering. As you see here, today we are going to study Introduction of Electrical Vehicle Architecture. So mainly we are going to study the basic architecture within the electrical vehicle. So these are the contents I am going to cover today, starting from the introduction, historical background and types of electrical vehicles, types of batteries, and what are the roles of power electronic converters and electric motors used in electrical vehicles and benefits, drawbacks, and I will close the presentation with conclusion. So first we have to understand there are large number of automobiles in use around the world, but what is the problem? It's not helping the environment and human life because they are causing air pollution and global warming and also rapid depletion of Earth's petroleum resources. So that is why we are going to the green resources, right? That is like renewable energy. So using the renewable energy, we will never run out of the energy problem because it's hugely available in the nature. So that is the to-go solution for to meet the demands of the future. So what is an electric car? So you can see the main architecture of the electrical vehicle. So we have power mains and also onboard battery charger. So the power mains we get 230 voltage AC, and that is converted into the DC voltage, and it is used to charge the battery. And we have the main component, that is battery, and that battery we have a DC-DC converter. Through the DC-DC converter it gives the supply to the internal components of the car. Again the same battery is giving power to the traction control, that is to drive the motor. So we have the input brake pedal and acceleration pedal. So this is actually giving power to the motor through traction control. So there is one more thing that we have to consider, that is actually mechanical braking system. So this component also has something called regenerative braking. So this system is responsible for braking the vehicle, also to generate excess power to charge the battery. So this is a bidirectional power flow. So whenever you accelerate the vehicle, the power is taken from the battery. But whenever we brake the car, whenever we brake the vehicle, the kinetic energy is converted into electrical energy, and that electrical energy is stored in the battery. So these are the general architecture of an electrical car. So this is actually a very green renewable source. It will not damage the environment, or it will not give any kind of emission to the atmosphere. So again, what is an electrical car? Electric car is actually propelled by electrical motors used and electrical energy stored in battery. So unlike vehicles with IC engines, right? So they do not produce exhaust gases during the operation because the IC engines, they pollute the atmosphere by emitting poisonous gases. But on other hand, electrical vehicle does not pollute the atmosphere, but also the power can be taken from the natural energy sources such as wind, solar, hydroelectric, or even biogas. So what are the historical background? So as you see here, firstly in 1884, Thomas Parker, they developed this electrical car. Even though this was the first electrical car developed by Thomas Parker, it was not commercialized until early 2000, right? Edison and an electrical car in 1913. So electrical car is not new. It existed since 19th century, but the platform or the ecosystem that is required to support the usage of electrical car So that is more important. So only now, only in yearly 2000, so we built the ecosystem. So that is the main reason. So when you think about an electrical car, more than the car or technology, the ecosystem and the people adapting to the new ecosystem is more important. So that is why we took more than 100 years to adapt to electrical vehicle. Even now, many people hesitate to move forward to electrical vehicle because they are worried about the same ecosystem. So ecosystem, it's need to be developed even more, so that like we will be able to replace almost all the vehicles that we see in the road to electrical vehicle. So like I said, it was invented in 1888. That was the world's first electrical car. So not just the car, you also see the bikes. How electrical car began to lose its position in the automobile market. How does it work? So like I said, when the pedal is pushed, we store the energy in a battery. The battery, we are using lithium iron phosphate batteries now. So electrical energy is stored in the battery, and the battery, whenever you push the pedal, it discharges the battery, and the controller, it drives the motor. How much speed we need, how much torque is required, depending on the optimization of the motor. So the controller drives the motor. So motor actually converts the electrical energy into the mechanical energy. Then the wheels are turned and the vehicle is moving. There are 3 types of electrical vehicles are available now. So first one, hybrid electrical vehicles. What is a hybrid electrical vehicles? We have electrical sources, also we have petrol or diesel, conventional. We also have a conventional energy source, but also we have electrical energy source. So we have both kind of sources available in same vehicle. That is why we say hybrid electrical vehicle. So that is, we have electrical energy, we also have conventional energy, that is from the petrol or diesel. We also have PHEV, that is plug-in hybrid electrical vehicle. As the name says, we have the plugged-in power. And also BEV, so it is actually battery electrical vehicle. It's solo, it has only the power from the battery. So you have to charge the battery, then you can use the car. If there is no charge, there is no other way to drive the car, you have to charge the battery to use it again. So battery electrical vehicle, like I said, runs entirely on the battery and electric drivetrain. It doesn't have any conventional IC engine. It's only powered by electrical energy. So this is a picture or construction of a battery electrical vehicle. So we have a battery, and the battery is charged by AC voltage, and the AC voltage is converted into DC, and we are charging the battery, and the charge energy inside the battery is used to drive an electrical motor. Mostly it will be like permanent magnet DC motor. So this is one of the competitive electrical car which is available in the market today. What is hybrid electrical vehicle? As the name says, we have 2 complementary drive system. One is a gasoline and another is an electrical motor. So where the HEV differs from the above 2 types of electrical vehicle is that HEV cannot be recharged from the power grid. The energy comes entirely from gasoline and regenerative braking. Yes. What is the important key factor here? We don't charge the battery by the means of electrical power. So when you drive the car with the help of gasoline engine, so the gasoline engine itself charges the battery, and also whenever you brake the car, the kinetic energy of the car is converted into electrical energy, and the electrical energy is stored in the battery. So that is the main difference here. So mainly the battery size or the power stored in the battery is not big compared to battery only electrical vehicle. Why? Because here the main source is only the gasoline engine, not the not the battery power. The main source is only gasoline engine. So gasoline engine, it's actually using the batteries to store the additional power. Whenever we have additional power, or the whenever we have the power being generated through regenerative braking, so we want to maximize those energy. So to effectively optimize the power generated by gasoline engine, we are using the battery power. So the excess power or the power being dissipated by the gasoline engine is stored in the battery, and they are used in the during the to support the car. So that we can improvise the efficiency of the converter. So that's the main point here. So this is the general architecture you can see. So we have a battery, we have a generator, we have an internal combustion engine. We have both. So internal combustion engine, right? It drives the shaft of my vehicle, but at the same time it's also running the generator, and the generator actually providing the power for the battery. So the output power from the combustion engine is always at the maximum, right? So you can think like that. So this generator, you can see this generator, it can operate as a generator, but also it can operate as a electrical motor, because it has both, right? So think about it, right? Now you are driving your car in a slope, right, down slope. So here you don't need a motor, but you need a generator to convert the excessive energy to generate a power, and the power is stored in the battery with the help of a generator. So this is a famous and well-known hybrid electrical car which is available in the market, Toyota Camry. What is the next step? Plug-in hybrid electrical vehicle. So that is shortly we say PHEV, can recharge the battery through both regenerative braking and plug-in to an external electrical charging outlet. So this is an advanced electrical vehicle. So here you can charge your battery with the help of kinetic energy and regenerative braking, but also you can charge your battery by the use of external AC source. So here the battery can be the main source also, and also it can also be a secondary source to harvest the excessive energy that is produced during the braking. So these are the Prius. These are the famous products available in the market, that is comes with plugged-in hybrid electric vehicle. So these are the main prototypes that we have here. How electrical engineering plays a major role in electrical vehicle. So how electrical engineering plays a major role in an electrical vehicle. So here the key is actually battery pack. So if you see here, we have a power converter, and what is the role of the power converter? We have a brushless DC motor in a wheel, right? So the power being generated is always AC. So that AC power needs to be converted into DC, and the DC power has to charge the battery. So the work of charging the battery is done by the power converter. One of the key elements of any electrical vehicle is battery. Energy density is measure of how much energy a battery can hold. The higher the energy density, the longer it will last before needing it to be recharged. So here what we need to understand, the power density is nothing but the amount of energy stored in the battery per kilogram. So the battery should be able to store maximum amount of power without needing a bulky or very heavy battery pack. That's the key. So it has to be very compact, it has to be very lightweight, but still it should be able to hold or store a very high amount of power. What are the types of batteries available? Lead acid battery, nickel metal hydride battery, lithium ion battery, lithium polymer battery, lithium ion phosphate battery. So now we are moving towards lithium ion phosphate battery. So some important terms which we need to understand when we talk about the batteries. First is capacity. What is the capacity? It is actually defined as a ampere hours. Ampere hour. So ampere hours available when a battery is discharged at a specific current, specified as a C rate. We say C rate. So 100% is OC. So what does it mean? Each battery has a rating, right? Current rating. Each battery has a current rating. Let's say there is a battery and the current rating is, let's say, 10 ampere. So what is the capacity? How long can this battery discharge this 10 ampere? Can it discharge 10 ampere current for 1 hour, 2 hour, or 90 minutes, or how many hours can the battery supply that current? So that is what we say capacity, right? So if your battery can supply 10 ampere for 2 hours, then what is the rating? 10 ampere for 2 hours. So 10 into 2, it's 20 ampere hour. So that is the capacity of a battery. What is state of charge? So again, battery capacity expressed as a percentage of maximum capacity. Again, the state of charge is nothing but the battery capacity, but not the rated value, but the available after being used for some time. Let's say again I said my battery capacity is 20 ampere hour, but I already used the battery for 1 hour supplying 10 ampere. So how much is left? 10 ampere hour is left, because 10 ampere it can supply for 2 hours. So 1 hour I already used. So another 1 hour my battery is able to supply 10 ampere. So what is the capacity then? What is the state of charge? It's the percentage of maximum capacity to the remaining. So that is means like 10 ampere hour is remaining, total is 20 ampere hour. So 50% is the state of charge. Then what is the depth of discharge? The percentage of battery capacity that has been discharged. Again, if you use the same example, we already have utilized 10 ampere for 1 hour. So 50% is depth of discharge. Energy, the total watt hours available when the battery is discharged at a specific current, specified as a C rate from 100% SOC. Energy is similar to capacity, but in capacity we only talk about ampere hour, but in energy we talk about the watt hour. So we will also include the voltage into current into hour. So we are talking about the energy, right? In energy watt hour, that is time multiplied by power. So in previous example I said my battery can supply 10 ampere for 2 hours. It's just like how much current it can supply. But now I am going to talk about how much power it can supply for how many hours. So my battery, it can give 500 watt for 1 hour. So I have a computer, let's say. The computer rating is maybe 200 watt. So how long can I use this computer if I connect this battery? 2 hours. So 2 hours means 1 hour is 200 watt. So 2 hours is 400 watt. So what is the energy? 400 watt hour. Right? Okay. So what is the work of a controller? So this unit manages of the flow of electrical energy delivered by traction battery, controlling the speed of the electric traction motor and torque it produces. So this is very key factor here. It's actually, if you see here, I have a battery and the battery is delivering power to drive my motor, but it can give any kind of voltage and any kind of current, but which voltage and which current is optimal to drive my motor efficiently, that is the key, right? So my motor has to operate at a maximum efficiency, and I should be able to get maximum torque, right? So that is the key. So that is why we are having a control. So this controller, it gets my input and what is my speed, and also it tries to efficiently operate my car, right? By analyzing my motor and speed and making it deliver maximum torque. Then DC to DC converter is a category of power converters, and it is an electrical circuit which converts a source of direct current from one level to another. So DC DC converter is again the converter. Input is DC, output is DC. But for example, my battery is 50 volt. But for example, my controller, it needs 110 voltage. Then I have to increase my voltage to 50 to 110. So here we need a step up converter, that is boost converter. So one level to another level, one voltage to other voltage, we need DC-DC converter. Again, this DC converter can be designed to transfer power in only one direction, from the input to output. However, almost all DC-DC converter topologies can be made bidirectional. A bidirectional converter can move power in either direction, which is useful in applications requiring regenerative braking. What is the point here? We are moving towards bidirectional DC-DC converter. So here there are both sides. Both sides can either be an input or it can also be an output. So good example is actually motor and wheels, and also battery to motor. So if you think about a battery and we have a motor, you want to drive the car using the power stored in the battery. So in this case, the battery power is used to drive the motor. So here the power is flowing from battery to motor. But at the same time, whenever you brake the car, right, the motor is operating as a generator, and the kinetic energy is converted into an electrical energy by the use of a generator, and this generator is actually giving the power back to the battery. So here battery becomes output and my motor / generator is actually becomes the input. So at one point of time when I am driving my car, battery is input and my motor is output. But when I am braking, my battery is output, my motor is input, because motor is operating as a generator. So what are the options I have? I have an isolated converter. What is an isolated converter? Isolated converter is nothing but the converter that has a transformer inside. So primary and secondary, they are not electrically connected or they are not physically connected, but they are magnetically connected. That is what it means, isolated converter. So what are the examples? We have half bridge, full bridge, flyback, forward and push-pull DC-DC converter. So these are the converters that has a transformer inside. So with the help of transformer, you can convert or you can send power from primary to the secondary. What is non-isolated converter? So here the primary and secondary, they are electrically connected, physically connected, right? So both input and output has a same ground. What are the options I have? Buck converter, boost converter, buck boost converter, cuck converter and charge pump converter. So these are the converters which does not have a transformer inside. So they are electrically and physically connected. So what are the motor used in an electrical vehicle? Brushless DC motor, permanent magnet synchronous motor, AC indexing motor and switch reluctance motor. So most of these motors, why are we using? It's very cheap and they are very reliable. Mainly they can also be used as a generator during the braking. It is similar to what is the brushless DC motor? It is similar to DC motor with permanent magnets. It is called brushless because it does not have the commutator and brush arrangement. The commutation is done electronically in the motor because of the BLDC motors are maintenance free. So that is what I said. This is the key. BLDC motors, they don't require a constant maintenance. Once you install in your vehicle, it's ready and it's good for several years. And also efficiency is over 95%, and they are very good for high power density. Right? This is the picture. This is how they are connected. In runner type BLDC motor. What is the benefit? The noise emission from electrical vehicles is very low. It does not pollute, right? By making unnecessary noise. It's not loud, and also they don't pollute the environment. There is no CO2. There is no carbon dioxide. In the near future, if particularly barely congested town centers are turned into zero emission zones, we will only be able to drive through them with high voltage vehicles. Right. The electric drive motor is very robust and requires little maintenance. It is only subject to minor mechanical wear. So only mechanical wear and tear are seen. It does not need maintenance like we do in IC engine. We have to change the oil filter, right? We have to change the oil every 5,000 years, right? There are like very complex maintenance work is expected in case of IC engine. But whereas in electrical motor, we don't need such mechanical maintenance. Electric drive motors have excellent torque and output characteristics. So which means they can be operated with high efficiency, right? And also it can accelerate very quick, very fast. It does not need a time like IC engine. They develop maximum torque from standstill. This allows an electrical vehicle to accelerate considerably faster than a vehicle with an IC engine. It can be stopped easily. It can also be started easily. What are the drawbacks? Main problem is the battery size and construction. It has a limited range due to battery size and construction. Charging a high voltage battery can take a really long time depending on the battery charge and power source. The network of electrical charging stations is sparse. We don't have electrical charging station across the nation. Whereas if you think about petrol bulb, we have everywhere, almost every cities, every villages, even every nooks and corners of even any village. Within 5 kilometers, you will be able to find one petrol station. But whereas in case of electrical charging station, it is very sparse. We are not able to locate as easy as we find petrol station. If the destination is beyond the range of electrical vehicle, the driver will need to plan the journey. In ahead of time, they have to plan the journey. Where can I charge my electrical vehicle on the road? This is very big problem. So what is the conclusion? We need to optimize the battery, right? We need to develop new battery technologies, and also we should be able to increase the efficiency of the converter. Once we solve the problem of saving the atmosphere and from the pollution, from the noise, but whereas the battery, if you think about a battery, it has limitations when it comes to the power, right, and cost. Heavy, when you buy a electrical vehicle, a significant amount of price is going to the battery, and also the reliability of the batteries. And there are so many complex analysis needs to be done to optimize the battery, and how we can improve the efficiency, and how we can handle the problem of protection of heat, how we can cool down the battery. All those things needs to be improved in future. So with this we come to following facts. The number of expected vehicles doubling on the roads in the near future. The need for the alternative energy is very evident and has promising returns. Important to produce vehicles that do less and have a longer range and use less energy, lower our toxic emissions and localize greenhouse effects. So all these solutions can be found in electrical vehicle, but where do we need to focus? The range, increasing the range and reliability of the batteries, and also monitoring the battery and increasing the lifespan of the battery and reducing the cost of the battery. All those are very important. Increase the overall energy efficiency of the car. It's also very important. Also, when you think about regenerative braking, we have to improve the efficiency. Not only we need to think about increasing the power density of a battery is important, but also how we can add energy from the atmosphere, or when you drive the car, you are also producing the energy. How we can bring it back to the useful energy, that's also very important. So now if you think about the power conversion of regenerative braking, it's only 25%, it's less than 25%. How we can improve the power conversion efficiency of a regenerative braking? We have to think, and also we have to improve the efficiency of every converter, every switching device, every inverter, and also another important thing is actually the quick charging. Quick charging. So in order to charge your car quicker, you have to increase the charging current or charging power. But when you increase the charging current or charging power, your battery will be taking very high current. But when your battery is taking high current, the temperature is also developed. The heat is developed inside the battery. So we need a good thermal insulation, and also the cooling also we need to incorporate to cool down the battery and to improve the lifespan of the battery. So these are the things that we need to consider. I hope we have a better idea of what electric vehicle is, and what are the major components of an electrical vehicle, and what are the issues that we are facing right now. In future, an electrical vehicle, an ideal electric vehicle, we have to reduce the price. How can we reduce the price? By increasing the lifespan of the battery, and also by bringing the cost of the battery down, and also to make a promising future for the young generation by giving a very clean energy across all the consumers. Thank you. So this is the end of my lecture. I hope you all understood the main points of electrical vehicle. Thank you.